Okay, so so this is kind of what I wanted to. So this is kind of like my. I kind of like this portfolio. A minimal mathematical kernel in Rust capable of lambda calculus, ski combinator evaluation, symbolic differentiation, and cellular automata simulation. Actually, you know, I don't think. So this should go to. This is honestly, I kind of like this. The only thing is I don't really have a. I need to make a YouTube video going. Okay. So yeah, so I think I want to continue working on. I should make a. So. Okay, hold on. Identity, yeah, that's easy. So hold on, let's just check that that is true. All right, so I guess we're not done because we need to add more tests, but I'm not gonna put it in a PR. So let's just do this. In recent cas8. This. Okay. Like this. Why does it keep getting invalidated? All right, a function that turns a function. Okay, so first off, function x applied to y gives y. So let's just go through this. Okay, so first, oh shit. Okay, so wait, how did I do this before? You have x-pers. Okay, so I think I should be able to do starting test case I see assert eq eval parse. That seems to be right. And let's just do that. Let's just do that. What's wrong with this? We don't have a. Because do I need to call parse on those things? Why don't I just put parse down in the thing? This E. We need a context. All right, I think we're good. So now I should be able to just okay, so now let's do function of x returns a function of y that returns x. Ooh, that's probably not gonna work, bro. I don't know if that's gonna work. Hell yeah, that did work. That's fucking cool, man. Wait, hold on. That's cool. Yo, my boy got lambda calculus. How do I hide this? There we go. Yeah, we got the omega. Alright, so let's add that one. That is so cool, bruh. I am a lambda calculus god. It's not all that... It's honestly not that impressive, but... Let me be excited about something, huh? Let me be excited about something. So, variable binding and shadowing. The inner X should be independent of the outer one. Check that renaming. Hold on, let's check. Honestly, what I care about is oh, damn it. See, that is not good. So what is happening here, though? We need a way to differentiate that this X is like a totally globally unique symbol. That's basically what's going on. Okay, so I got the ski. The ski is good. Okay, let's do these. Booleans and if then. Alright, we'll do that. Ooh, we should do that. Alright, so the only thing that really doesn't work is shadowing. The scoping, yeah. Because how do we do it? We simply build the rule. I wonder if it's easy to text for it and just say we don't support it. Can I look at the documentation of function and see if it says something about that? You know what? Slots is actually not that crazy. So that's hard, and I don't want to do that. So if I do a hold and a full form, does it write it, or does it's sort of... Oh, wait, I keep getting this. No, no. What? See, this doesn't say anything. So... Okay. Should we do, so I think I'm going to rename this to lambda calculus in cas3. I don't know how to do that. How do I make that work? Or how do I make, sorry, how do I make this one work? How do you, oh. With formal variables already automatically scoped. So wait, hold on. Let's just look at the behavior of function and see if there's anything we can do. So we build up these rules, and then we just replace them with it. So what we want to do is, the very first is check no, but what if you did, hold on. Wait, what if you go like 3 levels deep? Or wait. Because if I were to do Oh! Whoa! What is that right? Where the oh. Alright, we're gonna do that. How do I do a lambda? How do I write a lambda? And I should be able to apply this to A, right? But it doesn't actually so See, because that's kind of what I was expecting. I mean, that's very weird. Oops. But you know what? I wonder if I... Wow, that's so weird, bro. Oh my gosh, that breaks my mind. Yeah, thinking I found a bug. You just can't alias it, though. Because you're messing with the evaluation order. That is correct. That is exactly what you're supposed to do. But the thing is, in there, how can you get... I guess you gotta just rename them. But how do you get the outer X? This is so interesting, though. They're very sneaky. Very sneaky. Is this open source? But the thing is, Wait, hold on. So I want to know about... I want to see if this works. That's pretty crazy if it does. I guess a bunch of people have done this project. Wow, it's got a full... It doesn't have a parser, but it does have a 2-string. Wait, can we do the... This is going to be X... That's actually insane that that worked. But it doesn't rename any of them. But then let's test this. Wow. Oh, yeah. Because everything is of one argument? Is that true? Okay. Well, in any case, we don't really need this. Wait, hold on. Application. So is this supposed to be a abs? Does an app need to take... Oh, a beta reduction can only be performed when M is in abs. So hold on. So an application, so what's the free? Right. Okay. The helper function to generate a new variable that's not already used. Lambda calculus, boy. Lambda calculus. So yeah, the whole thing is replace free occurrences of var in expert with replacement. Um, uh, uh, yeah, I guess you just get a stop. Because once it's been shadowed, I guess that's true. I guess it's not that hard. Wait, hold on. If the bound variable... If the bound variable appears free in the replacement, rename it. Okay, wait, so we're trying to substitute... Dude, the fact that O3 can do this is pretty crazy. It won't be long. I do want to understand the lambda calculus, though. If the bound variable appears free in the replacement, what does that mean? Expert.var. That's the thing, though. This has to be an abs, right? Lol. Is this a trading bot, bro? Oh my gosh. Bro, are you joking? It's just a lambda calculus evaluator. This is the language I wrote, but GPT just wrote a lambda calculus evaluator, and I'm trying to make my language. I just added lambda, anonymous functions. But if you can see this, well, actually, this interestingly fails in Mathematica too. But we need to do this expression. And the problem is, this is supposed to be XX because this X is shadowed. So you're not supposed to actually replace. So once you replace A with, once you generate the rule, X to A, you don't actually want to replace it if it's not free. No, none of this has nothing to do with derivatives. Yeah. Lambda calculus. But I need to understand how this shadowing thing works so that I can fix my language. Yeah, how do you do a lambda in Haskell? I don't know. I never write Haskell. No. Come on, hurry up. So is the whole thing... Oh, this is why we can do this. Okay, so we have an abs, so we have a lambda. If the lambda's var is the same var... So if you have like a lambda x and then a lambda xx, then... I don't understand why you... Just subscribe. If you're around, you're around. You know how to reach me. I'm live all the time. Alright. The abs binds the variable we want to substitute. Do not substitute in its body. Oh! Wait, actually though, is that for real? Wait. Because I guess if you shadow... Then you're never gonna... You're never gonna use that... You're never gonna use this var if it gets shadowed. So yeah, you just return the expr. If the bound variable, so What does that mean? If the bound variable appears free in the replacement. Yeah, I want to understand that. Okay, wait. Let's see what it gave me. Okay. Alright, if this is var. So, okay, so this is a substitute function. And it could be any of the 3 types of x.prs. What does this mean? Oh, so replace this with this. Replace free occurrences of var with replacement. Okay, so there's no pair stuff. It's just, yeah. So that's okay. So if x.pr.name is equal to var, so in a name, wait, how does that work? If x.pr.name is equal to var, is var, so wait, can I just, can we do this? I wish there was a better REPL for Python. But let's just see if I can do this. That's the craziest thing to me, that you still cannot paste. Okay, so if I do, let's see. Oh, there's no repr? That's crazy. Okay, well, wait, actually, can I just do this? I wonder if that works. What's a body? Abs x. Oh, wait. Abs. Abs doesn't take a var, it just takes a name. See, that's weird. But it says it takes a var, but it doesn't actually take a var. Like it just takes a name. So like that. Oh, wait, okay, hold on. Alright, let's just see. So in this case, let's just read through substitute. So if expers of var in the variable we need to replace. Okay, so this is literally like sub var x var x var y. That's like super easy. Okay, so I should be able to say I don't know why it's like this. Like, that's a little bit weird. But that is true. Okay, fine. Else expert. Okay, so that checks out. Now you have a lambda. So now you're trying to substitute a variable, and it's just a name. That's what's annoying about with this var. Is it's just a name, and you're trying to. Okay, let's scroll down. When the expression is an abstraction. True. Abs x var x, replace x with var y. So this is the call. Substitute abs x x x var y. Since the abstraction binds x, the substitution does nothing and the result is still the identity. Y does not go into that. So that checks out. So that one's easy enough to do. So shadowing is easy enough to add. I believe because it's like a greedy thing. Only the next step matters. Because then it'll pass down. Right? So you know, if CF check F body for another F. If another F, then compare args. The thing is, it's a little bit more tricky because F allows multi-arg. Okay, but that's, that's part of the game. It's really not that hard. All you need to do is check that the intersection is whatever, and then only replace the ones out of the diff, which, since we're in Rust, we can do it, or since we're in like whatever, we can do it. So now this is the tricky part. I feel like this is probably if you have an app. Okay, well, let's keep going. So we're now in this branch. I should rename this stream. Portfolio is a terrible name. I mean, I'm trying to get this video done, but I feel like I just don't want to be a liar. I want to understand lambda calculus, and I want to do it properly. Is that so much to ask? Okay. B. The bound variable is different, which might cause capture. Before substituting in the body, we check if the bound variable Alright, so we have an lambda x, apply x to y. Wait, hold on. We're going too fast. Before substituting in the body, we check if the bound variable appears free in the replacement expression. Okay. Suppose we have abs x. Okay. Replace y with x. So okay, now we're getting onto the hard stuff. So now let's say that we do a probably ran out of battery. Okay, let's see. Lambda x, apply x to y. Actually, I don't know how that happened. Oh yeah, no, because he had died. But that's okay. Lambda x, apply x to y. Or apply y to x. I don't know how you're supposed to say it. And then we want to do a sub on that with replacing y with var x. So if we were to just go through and do that, naively, you get lambda x, x, x. When you say the bound variable, you mean what I think of as the binding variable. It's bound to the body. Okay. Check the bound variable. Here the abstraction binds x. That's true. The replacement is var x, whose free variables. Since x, the so that's the actual args, right? The replacement is the actual arg. It's the symbolic arg. So let me just... That's the funny thing about doing this is you end up writing the same thing over and over again because in different forms because your brain isn't like totally locked in that they're the same. So if we have an fx xy and we apply y. Or wait, no. We apply x, right? Is this the same, or am I tripping? When do you do this substitution? That's what I'm trying to say. Because what I did before was I made rewrite rules. X goes to X. Okay, let's just keep going. We will tie it into how cast works soon, but okay. All right, let's just take it for granted that we're doing this substitution. You know, somehow we got these rules to substitute. Okay, because I guess it could be like f of y. Yeah, right. Like, let's say you have f of y returns an f of x, x, y. And then you apply the x to y. Then you would generate the rule y to x. So that would be a case when you actually get this substitution. But so then we're about to do this application. We're about to rewrite f of x, x, y with the rule y goes to x. But then we check the right-hand side of the rule, and we look, and we say, what are the free variables in this thing? And it's x. Since x, the bound variable, is in the free variables of the replacement, there's a risk of variable capture. So there's a risk, basically, that, because what is it supposed to be? I can just do this, right? Oh yeah, okay. So if I do lambda y lambda x, do I have to do the dot? X, y. I wish there was better, whatever. So first off, this should be good, right? Nothing happens? Or is it like busted? Is there application in this, or is it just beta reductions? I'm guessing that this thing is pretty complete. Well, you know what? I trust Mathematica, and I know how to write it in Mathematica, so let's just do that. So if I have function y, function x, x of y, and then this is an x. See, there we go. So that's kind of what I wanted to know. So what does the $sign mean? What's up with variables with dollars at the end of it? But the good thing is that you should still be able to do this. Right? So it's not like, because it's a lambda, in some ways it doesn't matter what its name is, right? So so we finally found the case. You know what? I'm being a baby because I should just admit, look, we're going to grind through it and we're going to have full lambda calculus support at the end of this. Because then I am not like a loser. You know what's interesting? Now that I'm coming back to software after doing mechanical stuff for like 6 months, is I'm like, actually almost a year. I haven't really written. It's like when you're designing something mechanical, you're always like, hey, I'm positive that this thing, like, you know what, I can always just go balls to the wall and find a way out of this when an issue arises. But I'm less confident when it comes to software. I'm like, can I really solve this? Like, is there a way to get around this? You know, I found a reason why playing guitar actually is a bad idea. I don't play with a pick, and my my right index finger is gotten kind of callous. So now when I use the trackpad on my shitty Dell laptop, I can't even fucking move it. A little bit crazy. All right, so let's finish this thing. So we found a case where capture occurs. This case is really funny. You can't alias function. They should actually not let you do that because you totally bonker the freaking evaluation order. All right. Okay, it's pretty good. Check this out. So I can now do function x function x and it recurses. So in that sense, the lambda calculus works. So, you know, lambda functions are working. In a much more real sense, though, it's broken because, let's see, what's broken? First off, function. What's the case that's broken? Let's go up. It's this case, the shadowing. So let's actually put this into the failing cases so that I have it. Okay, so this case is a Okay, so this is going to be a function of x that returns a function of x that returns x. So it's a function that takes one argument that returns the identity function. And then you apply that, so you go like this. So this, and then this closes this, and then you need an A in this. And so what you're supposed to, oops, not that. And what you're supposed to get is you're supposed to get function x, x. Because when you see that this thing gets shadowed, you don't actually do the replacement. So you stop. You say, hey, look, even though we got this rule that we have to do this substitution, we looked here and we said, hey, bro, stop, stop, stop. Don't do it. Don't do it. So that is bugged. So if I write this out, if I copy this into my thing, I'm going to get function A of A. So technically that's wrong. Now, the much more important thing that's wrong is the capture case. So I actually want to know how I do on a capture. So this is a shadow test. And let's do a... And this is going to be a capture test. Bro, I freaking love computer science. These lambdas, it's going to be so sick when I can do math with like church numbers in my language. Okay, so, but I think the only way that that's going to fully work is if I get true lambda calculus with shadow and capture. Because I think that shadow and capture is the only thing that I don't handle. Omega capture should not terminate. That is correct. That's true. I'm pretty sure... Oh, I guess we should probably try to get the SKI common error system working in lambdas. I actually want to know. Okay, so if we have a function x, function y, x, set k, and so the problem is you can't just set k to it. You need to set k pattern, I don't know, z. Actually, no, I think you could just set k to this. So then if I do k of x, or k of a, no matter what, it returns A. So I think that that works. But we should do a test that... See, I think that this is wrong. Or no, it's not wrong because it's... Okay, so hold on. Alright, so wait. Let me make a readme. I'm gonna... just store some shit here. This is probably true. Alright, so let's do SKK. I don't think that's gonna work. I think because... this application is like left associative, I think you have to do like a this type of thing. Oops. What happened? Why do we panic? We should never panic. Wait, hold on. Panic on an assert? We probably figured that out. What's up with that assert, man? That should reduce to A. Okay, well, we'll get there. We'll get there. We'll do all the rest of it. But let's get the capture one down. So the capture one is this one. It's, it's this. So it's function y, function x, xy. And then we apply it. X. So yeah, so see, this is supposed to be yeah, some sort of weird, like, renamed, these two are X, but then this guy, okay. See, they do X dollar. Wait, actually, wait, but I think that this is, GPT is probably smart enough. Because the dollar is definitely... But the dollar probably has like a... God, I hope this isn't like too hard. A pence dollar that's fresh. Okay, hold on. But can I evaluate this? What does this do? Yeah, that's fine. But the full form of that is like a, the same. It's not any different. Can I actually do, like, X dollar? Oh shit, that looks like a parser bug. Oh shit. I hate parser bugs because I don't like parsing. Okay. Well, it's okay, but... See, that's amazing, though. Like, how do I even do that? I never handled multiple scopes. Multiple contexts, I never did that. But where's the documentation on it? Like, yeah, because I would prefer to just have to do, like, what is it? Yeah, so I would prefer if we just had to do function x1 x1 x, that kind of, like, that would be nice to me. I had to think about it. The unique function shows how Mathematica generates. Okay. Okay, that's probably true. It's a system generated symbol. So, but like, okay. Let's go even one level deeper. So if we have this, what happens if I, okay. So now, I think I have to go, I have to do another shadowing, or another capture. I could ask GPT to do that. I don't think that this is even right. So it doesn't really get it, right? Alright, so we need to be smart then. We actually need to think with our minds. So how could I get... Wait, I think that this is not gonna, yeah. I think I need a... Yeah, but that's fine. That's like not what I'm talking about. Okay, so what do we have? We have... So is this the shadowing case? No, this is the... So then you get f of x dollar x. Okay. So you get f x. That's this. Okay, let's just try this. Fy fx fz fx. Will that give me what I'm talking about? And then what's the final thing going to be? It's going to be like a x, y, y of z. I don't know. That's a fusion or something like that. But like, but this is the body, but this is not the app. The app needs to be something where we give it like an x. I guess we could have it be, let's try this. Function z, function y, function x, function x again. But then isn't that, no, but see, that's an immediate shadow. So you need like an intermediate guy, right? Or am I tripping? God, why am I so dumb? I wish I was smarter, because then I could instantly come up with something where two captures happen. I need to make some food. I literally have not eaten at all today, except for that freaking gross ass donut that I would eat about 10 of. Ugh. What should I make? There probably are cool ways to do like a search to find lambda terms with like certain properties or something. I don't know how you enumerate lambda terms though. I don't know. Maybe we don't need to do that. I think it's possible that it's... This is one symbol, right? Yeah, so that's one symbol. So, but if we were to do this, we get two evaluations. So we need to fix the parser. Okay, so there's the parser bug. There's the shadow. And then there's this module number thing that I guess I'm going to have to do. Dude, whenever you look into this, I swear, whenever you look into Mathematica, you're always like, bro, what is going on in there? Because is that dollar sign, like, are they just hiding the module number, or... I'm fucking crashing out. Okay. Let's just say... Let's just try to do a unique thing. So whenever unique is called, it increments it, right? I thought that that's what that did. Wait. Oh, wait, they're totally different. They're like so high. Oh, because it's getting called like a bajillion times? That's crazy. I wonder how much this is incrementing by. Whoa. That's so weird. Bro, this language is so trippy. So unique gets called... Unique and module get called a total of 469 times every time you call unique. Wait, hold on. And in 1 plus 1... What the... What the Sigma? Okay. So... Look, we know it works. I don't know why I'm freaking out about whether or not it has a dollar at the end of it or whether or not it has a dollar and a number. Under some circumstances, convenient to explicitly to return symbols that are generated inside modules. But like, can't you do something like... Can't you do something like... Wait, what? How is that? How does incrementing the module number? How do we know that? How do we know that we didn't already? So maybe I'm not going to do a full module system, and I'm just going to do this janky thing where we check. We check. It didn't understand my question at all, but that's okay. All right, so where are we? We are, I believe we're here at example D. Oh man. Here's the expression. Oh wait, here's the expression. In this case, that is sounds out of tune. Sounds a little sharp. Okay, so we replace a shadow is like kind of fine. Like I actually don't. Wait, what is the shadowing example? Oh, okay. So, but you can't just replace it in the body. Or I guess this can be considered the body. Wait, sub app. It is kind of amazing that in 100 lines of code you can write a lambda calculus thing. I never really went through and tried to understand lambda calculus. Oh. How do they... Wait, what does that even mean? Oh, weird. Dude, weird. Oh, that's so funny. It's like how most of the genetic code is just to like rewrite so that you don't have to deal with the framework of the genetic code. Jesus. So how do they... Okay, so how do they keep track of free vars? How do I get the free variables of a... Because you still need to know this. But hold on. Okay, instead of getting hung up on the fact that I don't know how I'm going to be able to do that, let's just say, okay, so we see that in the replacements free variables occurs the expr.var. So this is the abstraction. Can we just rename abs to lamb? Lamb makes way more sense than abs. But that's okay. Dude, I really want to know how church nats and church numerals work. So, in Boolean algebra, and how you can do everything with lambda calculus. I never really saw how you could really do everything with lambda calculus, and I still don't. But okay, the var is the bound variable name. Okay, so this is a lambda x. So x in replacement maybe in practice it's not going to be that crazy to do a total search to find. Oh, isn't it called sims? That's not even a thing. You have to write it yourself. So I wonder how they know. Alright, whatever. Come on. I'm getting totally stuck on that. How do they know? Yeah, because you also don't want to overlap with any of those. Because, like, if you had f x x x1, you're substituting, or this x1 x x to x1, or no, the other way around. X x1. Oh wait. Okay. Yeah. If it's not, just do it. Okay, now if you have an application, you just recurse. Okay, so that actually makes some sense. The only question I have, I guess, right now is why would it be just as valid to replace the replacement It's probably not. Why not? All right, so I pretty much understand substitute. Now we need to understand beta reduce, and then I guess that's it. So this is a lambda, then it does the replacement here. So this is really just the whole thing, huh? Alpha convert. Is that a real thing? It's interesting that they say might, because I think I would probably say that it definitely does, but I guess might is probably... If you want to perform lambda x m, what is that? What is in that brackets? That must be some... I don't know that notation. Whoa, is it coming up with some new shit? That's crazy. That's a crazy generation, huh? That makes sense, though. Conceptually, I understand why I would want to... Or just like at a high intuitive level, I feel like I kind of understand why. have like a The thing is, like, what does it matter if it's in a pattern? Does it matter? Oh, but you know what? It probably... Hold on. But, like... Wait, does this overwrite or do I need to do it with a... Oh, wait, but that doesn't really... Oh my god, that's breaking my brain. Because it actually is a way... That's how you really gotta do this thing, man. You gotta keep track of all this stuff. But see, I'm pretty sure if I did that... Wait, hold on. Clear. A function of x sends a set delayed f pattern x blank. Oh, it doesn't even tell me though. That's the funny thing. I mean, yeah, it returns null, but like... let's say... Yeah, so it still works, but well, yeah, okay. So, okay, but in this case, the rewriting of y on all of this doesn't actually affect anything because it's still... But but the correct thing to do is still to stop when you see the shadow. But, well, actually, but in this case... I wonder if it does. Oh, God. Okay, so beta reduction is if the function part is an abstraction. So you have an expert and it's an app. So then you take the body and you substitute the var for the arg in the body. Okay. If it's not, if you have an app to an app. Okay, so this arm I need to understand. I didn't even think about that needing so much special care. Pew 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 pew. Okay, so let's say you have like so okay, wait. Did they go through the fuck. How do I get back to where I was at? It's so freaking cool. It's so cool that this is what lambda calculus is, man. And with this simple setup, you really can do everything. All right, I'm capping out, bro. I can't look at these symbols anymore. All right, but I understand lambda calculus a lot more now, and I'm gonna I really want to get this thing to be a true lambda calculus evaluator. I can just store like a special name in my table, in my context. Oh, I'm probably gonna have so many issues with like okay.